the townspeople gathered together for the most important event of the year, the election of the Root Bridge. By the time we're done here, we will walk through the process that Spanning Tree Protocol uses when electing the Root Bridge, which just happens to be the most important switch ever. CBT Learning Content Team, that is how you spell EVA. No correction needed there. So do you guys remember early on when I was talking in the Spanning Tree kind of introduction, I said, remember the simplicity because we're going to add complexity as we go? Well, that's what we're doing, but it's actually much needed complexity because this video walks through the process that Spanning Tree is going to use to pick the most important switch of the network. And hang on, before I go any further, why do I say that? Remember, the whole algorithm of Spanning Tree is based around the center of the network. And the center of the network is the root bridge. And it just so happens to be one of the very few things that we have control over is that election. So it behooves us to know how this happens. So out of the box, we know that a root bridge will be elected. How does that happen? Well, the rule says the switch with the lowest bridge ID will become the root bridge. Okay, what's the bridge ID? Well, it's these two puzzle pieces combined into one. The bridge priority, which if you have a standards compliant switch, meaning one that follows the industry standards, RFC standards, and is manufactured by a reputable vendor, it will have a default priority of 32,768. Now, it seems really random, but I'll explain why it's that way in a second. Then you have the bridge MAC address. Every switch, when you pull it out of the box, has a burned-in MAC address. Matter of fact, let me bring this up right here. This is Arizona Switch 1. I'm going to log in, and I'm going to type in show version, right? You actually see this output when you first boot the switch. You can see all the blah, 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 cryptographic information. Oh, right there. Right there. Base Ethernet MAC address. This MAC address right here is kind of like the MAC address that's assigned to the chassis of the switch. Like the box itself has that MAC address. You can't change it. You can't modify it. It's burned in there. And I know some of the MAC addresses you can change. You can say, well, spoof this one, not this one. This one can't be changed. And that is what is used for the Spanning Tree root bridge election. So what the switch does, and the switch does this by itself when it's running Spanning Tree, it boots up, it takes that priority, 32,768, tacks it onto the front of the MAC address, and sends it out every single interface once every, you remember the time? 2 seconds. Because that little bridge priority is inside of the BPDU, the Bridge Protocol Data Unit, which tells all kind. This is like the sonar of Spanning Tree. It's the one that loops around the network and actually informs the switches that they're a loop because they can see their own BPDU come back to them. Well, inside of that BPDU is the bridge ID, so it also acts as an election ballot. So at any given point in time in the network, if a switch comes along, it's like, hey, check out my BPDU. And inside of there, it has a bridge priority, or a bridge ID that is lower than the current root bridge. Then, bam, that guy immediately becomes the root bridge. Well, first off, how do you figure out which one of these is lower? Well, we know they're all 32,768 by default. We go, okay, that's the same. So same, they got 0. Okay, same, that's the same. Okay, difference, okay. Which one of these is lower, A or 1? Well, hexadecimal is 0 through 9 and then A through F. So 1 is right there. So right there. You've broken the tie. That is the lowest bridge ID. So whichever one of these switches has that as its MAC address becomes the root bridge. And will stay the root bridge until something comes along that has a lower bridge ID. Now, if we can't change the MAC address that's burned in there, we saw that with show version, how do you think we can influence the election? I think you've got it. You change the priority. That's the one configuration option that we can change. We can take that down. So let's just say this one has that bridge ID. Well, we can come in there and say, I want that to be 4,096. You might be, well, why'd you pick that? I'll explain that in a second. But by doing that, you exempt, I mean, it doesn't even get that far. As soon as it gets right here, it's like, oh, that's lower. You win the election. You are now the root bridge. So I want to take you back to Arizona, where all of our folks are eagerly waiting that election, because I want to determine which one of those switches is the root bridge. And I want to show you the big show command that you can use to do this. There's actually not that many show commands that are really relevant for spanning tree, but the ones that you do use, you want to know really well. So here it is. Let me bring up the console prompt. We've still got our show version output out right there. So you might just glance at that MAC address one more time. We'll see it again. I'm going to type in the command, show spanning tree. Enter, right? So let me scroll right up to right where the output comes out. Now, first of all, this switch will run per VLAN spanning tree. If you remember the different versions of spanning tree that we were talking about, where we had the original common spanning tree, and then Cisco came out with a proprietary one called per VLAN spanning tree, they always have their switches run their version by default. So you can see right here, per VLAN spanning tree, so for VLAN 1, it's saying per VLAN 1, here's what we've got. Spanning tree is enabled, and it's using protocol IEEE. What's that mean? That means we're running the older version of spanning tree. It doesn't say 802.1d. It actually says IEEE, which is kind of its own way of saying the same thing. The original spanning tree, the one that takes 30 to 50 seconds to figure out that there's a failure and recover from it. So we'll want to change that over when it's all said and done. But before we do, the root bridge calculation is the same. So look at this. If we scroll down a little bit more, let me scroll down right there. There we go. You can see two relevant sections. I'm going to grab my pen and box them out. This guy right here, and then right below, hang on, let me change pen colors because I want it to really be distinguished. This guy right here. This guy up at the top is the root bridge info, right? So if you want to know who is the root bridge of the network, this is all the information about it. The root bridge happens to be somebody who has the priority 32,769. That concerns you. I'll explain it in just a second. They have the MAC address of this. The cost to reach them is 4. Do you remember those costs? I remember 100 megabit per second was 19. I remember, that's right, gigabit per second was a cost of 4. Remember the number one tiebreaker that spanning tree uses is the cost. So it's saying, okay, I can get to the spanning tree root bridge just through the cost of 4. So that tells me that I'm probably directly connected to it with a gigabit per second connection. And that can kind of give me a hint as who it is too. So right below that it says, here's the port that I use to reach the root bridge, right? I go out gigabit Ethernet 2/0/1. So again, it's like, it's only one hop away, and I go out this port. It's almost like pop quiz. Who do you think it is? So I'm saying hello. This is the BPDU once every 2 seconds, right? And there's some other timer information there, but for now, this is the info about the root bridge. Now, this is the information about me, bridge ID. This is me. I am 32,769, same as this. Now, it's telling you I calculate that because I have the default priority of 32,768 plus a system ID extension of 1. Come on. Make it simple. It's not. So per VLAN spanning tree, what it does is it actually adds the VLAN number to the priority every single time. So if you're so remember I said default priority is always, you take it out of the box, 32,768. Well, in Cisco's world, if you're running per VLAN spanning tree, they say plus the VLAN number, which they call the system ID extension. So we're talking about VLAN 1, right? Right there. So it's saying I'm going to add 1. But good news is the root bridge did it too. You can see 769 right there. And we'll see that again and again. I'll explain why on that a little bit later. This is my MAC address. Okay, that should look a little familiar. Look at those last 4 digits. D900. Now let me hide my pen for just a second. That's right. D900. That's the burned in base MAC address, right? So we can see that and get my pen back there. That's the MAC address that it's using for the selection. We can't change that. We can modify the priority, but we can't change that MAC address. I'm saying hello every 2 seconds, and then further time, aging time, max age, blah blah blah. That's how long until it considers a switch dead, and so on and so forth. But for now, so I want you to catch. This is the information for 2 different switches, right? You got that? This is the root. This is my switch, AZ switch 01, the one that I'm on right now. Let's scroll down a little bit more because this is really good info. This is the interfaces that are running spanning tree and their status. It says gigabit 2/0/1 happens to be a root port. Now, that doesn't mean it's the root bridge. That means it's a root port. I go out this port to reach the root bridge. Remember this right here? That's the port it's going to use. And it's telling me I've got a status of forwarding. So that port is active. That's good. And it's a cost of 4 to get to the root bridge. Now, it's saying this one right here, 2/0/2, that's this guy, is considered an alternate port. And the fact is, sorry, Charlie, it's blocked. So this is down. It's also a cost of 4 to reach the root bridge that way, and that's fine. And then right here, it's saying, oh, and by the way, this guy right here, that's a designated port. A designated port is simply a port that is forwarding. If you were to plug in a computer to that switch right there, it would be a designated port. It's just, I am forwarding. That's all I'm saying. So it's saying this port right here is forwarding traffic. And that's the reason why is because this switch right there is probably using this guy to reach the root bridge. Or maybe it's blocked on this other side. We'll have to find that out in just a little bit. So this screen right here really allows us to see all the information about spanning tree and help us determine which switch is the root and what the impact of that is on all the interfaces. So if I were to fill out a diagram right now, I would be like, okay, this guy is, oh, hang on. That guy was forwarding. I just did it backward. That guy was blocked. This guy was forwarding. This was the designated port. This was the root port. This is what it's using to reach the root. And then this one is the blocked port, right? Now, what do you think? Chances are pretty good this guy right here is the root bridge. You want to see him? Well, I just moved the console cable over, so let's bring this back up. All right, so hit the enter key a couple times. We're now logging into switch 2. I'll type in that same show command, show spanning tree. Hit the enter key, and look at this. We've got VLAN 1. Scroll down a little bit. Root ID. So once again, we've got our two little bracketed sections. This is the person that is the root. This priority, this MAC address, and all. Oh, wait a sec. This bridge is the root, which is actually really surprising to me. I fully expected that the root bridge would be this guy right here because I figured that would be the oldest switch on the network. But this one, for whatever reason, Cisco used a burned in MAC address on this guy that is actually lower than their older switch. I didn't see that coming. I didn't expect that. So that's news to me. So right below that, and you can see this is saying, and this is me. And notice a similarity. It's like, oh, by the way, MAC address, same as this, right? Look at what it gets because it's the root bridge. Scroll down a little bit more. Every single port is forwarding. Every single time. Forward, forward, forward. Now, I'm going to hit the space bar because I want you to see we are running per VLAN spanning tree. There's VLAN 10. I'm the root of that guy too. Hit the space bar. There's VLAN 20. I'm the root of that one too. It's the root every single time. And remember, this is what Cisco does. They take that default priority and add the VLAN number to it. So you can see the priority on VLAN 20. This is how it's helping to distinguish the BPDUs. The priority goes up by an increment of 20. Truth be told, there's more to that increased priority than just how to tell the difference between the VLANs. When Cisco made the spanning tree proprietary, meaning they said we are going to have our own per VLAN spanning tree and per VLAN rapid spanning tree, they made it to where it is proprietary, but it still works with all the other switches that are out there. The way they did it is they stole some of the bits that you're using for the priority. So let me just go back to the slide and draw it up real quick. When you're looking at the priority, you actually have options of 0 to 65,536. That's the industry standard spanning tree protocol. So you could actually have switches at 65,000 different levels. Well, Cisco looked at that and they're like, you're never going to use that. So why don't we, we'll go into the protocol itself and we'll steal some of the bits. We'll leave some bits for the priority over there, but we'll take some bits that we're going to use for our VLAN number. So they they tweaked the standard, but they tweaked it in such a way that it was still compatible with all the other switches that are out there. It's just the other switches won't recognize that you're running it on a per VLAN basis. But that's the technical reason why the priority goes up when you see the VLAN numbers go up. It's because we're using stolen bits, which just naturally increases the priority. So at this point, here's what I want you to walk away from this video with. I want you to understand how the root bridge gets elected. It does so through the bridge ID. The one with the lower bridge ID wins. What is the bridge ID? Combination of the priority and the MAC address. How do you figure that out if you're on a switch? How do you figure out which one is the root bridge? Every single time, use that command, show spanning tree. And inside of there, you'll see the information for the root bridge and the local switch, the one that you're on when you type that command, as well as the status of all the ports. And you can use that information to really trace down who the root bridge is. In the next video, I want to show you how you can change that so that you can have control over who that root bridge will be. For now, we have walked through the process that Spanning Tree uses when electing the root bridge, the most important switch ever. I hope this has been informative for you, and I'd like to thank you for viewing.